Welcome to the world of oblique asymptotes. In this lesson, we'll explore a fascinating aspect of functions, where they approach certain lines as x heads towards infinity. These lines aren't your typical horizontal or vertical asymptotes. They are called oblique or slant asymptotes. Let us uncover what makes them unique and how to work with them. So, what are oblique asymptotes? Well, when we have a rational function like f of x equals a square plus x plus c over x plus e, and the degree of the numerator is 1 greater than the degree of the denominator, the graph has an oblique or slant line asymptote. An oblique asymptote is a slant or diagonal line that the graph of f of x approaches as x goes to positive or negative infinity. This line represents the long-term behavior of the function. To find this oblique asymptote, you can perform polynomial long division or synthetic division to simplify the function. So, let's start with an example. Let us say that y is equal to x squared plus 5x plus 6 divided by x plus 3. Is there any horizontal asymptote? The degree of the numerator is 2 and the degree of the denominator is 1. So it is top-heavy. So, remember, whenever it is top-heavy, there is no horizontal asymptote. But is there a slant asymptote? If the degree of the numerator exceeds the denominator by exactly 1, then there is a slant or an oblique asymptote. If the numerator exceeds the denominator by more than 1, there is no slant asymptote or oblique asymptote. So how do we go about finding the slant asymptote? In order to find it, you need to use long division. So we have to divide the numerator by the denominator. The numerator is going to go on the inside. Let us divide x squared by x, which is x next, multiply x by x, which is x squared, and x by 3, which is 3x after that, subtract. X squared minus x squared is 0, and 5x minus 3x is 2x, bring down the 6. Now let us divide again. 2x divided by x is 2. And then let us subtract. And then let us multiply first 2 times x is 2x, and then 2 times 3 is 6. So there is no remainder in this case, we're just going to get 0. So what we have on top here is the slant asymptote, and it is an equation, y equals 2x plus 2. That is how you find it. Now, what about this one? 2x cubed minus 8x plus 6 divided by x squared plus 4. Notice that the degree of the numerator exceeds the denominator by 1. So therefore, there exists a slant asymptote. Let us divide. Don't forget about the 0x squared. You need to write that in order to divide it correctly. So let us divide 2x cubed by x squared. That is going to be 2x. Then multiply 2x times x squared. That is 2x cubed, and 2x times 4. That is 8x, which I'm going to put here. Now let us subtract. So 2x cubed minus 2x cubed will equal 0, negative 8x minus positive 8x. That is negative 16x, and we can bring down the 6. So we can divide negative 16x by x squared. So therefore this is the remainder. We don't need to worry about the remainder. The slant asymptote is what you see on here. So slant asymptote is simply just 2x. In conclusion, oblique asymptotes are slant lines that rational functions approach as x goes to infinity. They help us understand the function's behavior in the long run. By dividing the function, we find the equation of the oblique asymptote. Thanks for joining this lesson, and I appreciate your effort in learning about oblique asymptotes. Happy math!